Hello everyone, I hope everyone is doing well. In this video, we will draw the shear force and bending moment diagram for this beam. We have a beam where there are reaction forces. 17 kilonewton is acting here on this support and 19 kilonewton is acting on this support. We have a point load 12 kilonewton acting downward and we have a uniformly distributed load 4 kilonewton per meter which is acting over 6 meter span of the beam. So we will find the shear forces in this region 1, 2 and 3 here. So first we will find the shear forces, then we will draw the shear force diagram. So shear force at section 1. Shear force at section 1, we know all forces on the left hand side of this section we just add. So it is only 17. So we will have 17 kilonewton here. Shear forces at 2, we have to write shear forces at 2 is 17 kilonewton minus 12 kilonewton which is 5 kilonewton. Upward I am taking positive, downward negative, that's why 17 minus 12. Now shear forces at section 3. Shear forces at section 3, we have 17 kilonewton upward minus 12 kilonewton downward, and then we have this uniformly distributed load. And that uniformly distributed load is 4 kilonewton per meter. And it is on how much meter? 6 meter. So we have minus 4 times 6. Because 4 kilonewton per meter, but it is totally acting on 6 meter. So 4 times 6 is the intensity of the load. And that's it. So we have 17 minus 12 is 5 kilonewton minus 4 times 6 which is 24, and we have 19, so minus 20, we have 5 here. So if I simplify, so it is 5 minus 24, it will be minus 19 kilonewton. So at section 3 we have minus 19. And then at the end, if we add this reaction force which is 19 kilonewton, it will become 0. Now if I want to draw the shear force diagram, how I will draw? Same, like we have this point, let's say, and we have this point. Here we have this point. Now shear force at this region, which is section 1, is 17 kilonewton. So let's say this is 17 kilonewton. So I will go straight from here, 17 kilonewton, and it is acting till this point, the 17 kilonewton. Then at section 2 we have 5 kilonewton. So from 17 I will come down to 5. Let's say this is 5. This is 5 kilonewton, and this 5 is acting till this point, the UDL, the start of the UDL, and it is here. Then we have to go to section 3 where the force is how much? 19 kilonewton. So 19 is where? It will be somewhere here. Let's say this point is 19. Minus 19 kilonewton. Now I will go from here to here, 19. So I will not go straight downward to 19. Why? Because here we have a uniformly distributed load, and as I go from this side, the force increases, and the shear force, when we reach here, it is 19. It is not 19 here, not here, not here. It is at this section after the UDL finishing. So from here I will go down like it is decreasing from 5 to minus 19 it is going. So it will go like from here to 0 and then it will go straight to 19. Let's say this is 19. So it is an inclined line here. This is straight inclined line. So UDL, uniformly distributed load, when there is a shear force due to uniformly distributed load, we show that in the shear force diagram with the help of an inclined line. Right? And then we have this 19 till the end of the beam, and once we add this 19 to it, it becomes 0. So we have 17 kilonewton here. As you see, we have 5 kilonewton here, and we have minus 19 kilonewton here. So these are the shear forces, and this is the shear force diagram. Now in the next step, what we will do? We will find the bending moment. And the bending moment, we will find the bending moment where? We will find the bending moment at this point. Let's say this is, we name it, let's say point A, because here one force is acting 12 kilonewton, so maybe there is maximum bending moment, we don't know, so we find it here at point A. We find here at the start of UDL, let's say point B. We also find at point B, and we find at the end of the UDL also. Let's say this is point C. And we know that in the start of the beam it is 0, and at the end of the beam it will be 0. So let me find bending moment at point A. So bending moment at point A is what? This distance is 3 meters. So 17 times 3. 17 times 3 is how much? 51 kilonewton meter. Then bending moment at point B, I have to find. And that will be 17 times 3 plus 2, 5. 17 times 5. And this 12 kilonewton is acting downward, so minus 12 times the distance, which is 2. And that's it. This 17 times 5 minus 12 times 2, it is equal to 61 kilonewton meter. 61 kilonewton meter. Now we need to find at point C. So bending moment at point C, this is equal to 17 times the total distance, which is 3 plus 2 plus 6, right? So 17 times 11 minus 12 times 2 plus 8 minus 12 times 8. Then we have this UDL. Now we are not finding shear force, we are finding bending moment. So this UDL is, we need to convert it into a point load. So that UDL, if we want to convert it into point load, we will show it in the center of the UDL. And the intensity of the UDL will be 6 times 4. So we have 6 meter total and 4 kilonewton per meter. So it will be 24 kilonewton. And it will be acting here from this point will be 3 meter. Because it is acting over 6 meter span. So we divide it into half and show the point load at the center of the 6 meter, which is 3 meter from point C. So if you don't know how to convert this UDL into point load, so you can watch the video which I have put it in the description. We have already solved. So now we will have a moment at point C due to this UDL, which is now point load 24. So minus 24 times 3, because the distance here is 3 meters. And once you do this calculation, 17 times 11 minus 12 times 8 minus 24 times 3. So here you get minus 19 plus 19 kilonewton meter. We have 19 kilonewton meter from here. So this is how we found the bending moment at point A, point B and point C. Point A, point B and point C. And we know that at this support and at this support it will be 0. So now what we have to do? We have to draw. Right? So to draw the shear force, what I will do? Look here. I have found at point A, so let's say this is point A. I will show with the help of the scale, so it will be looking good. So let's say this is point A. We found at point B, and we know at this point, which is C. Right? So here we know. Now at point A, B and C. At point A, how much is the bending moment? 51 kilonewton. So let's say here this is 51. So from here to, I will go straight to 51. Let's say this is 51. So from 0, I will go straight to 51. Then at point P, here, it is 61, so I will go from 51 to 61. This point is 51, this one is 61. Then now there is a trick. Look here. At this point, the UDL starts. The UDL starts, and I told you before that whenever the shear force diagram cuts the 0 line, we will have maximum bending moment at that point. Right? So this UDL start, and this UDL is increasing from here to here. So initially we have less UDL, and then it is increasing. The UDL, I mean the force. So what is happening? From here we have 61 kilonewton meter, the bending moment, and then we at the end we have 19 kilonewton meter, which we have calculated here. So I will go from 61 to 19. But look here, this 61 is not my maximum bending moment. Why? Because the 0 point is here. So it means the maximum bending moment is somewhere where the shear force diagram crosses the 0 line. So what I will do, and it is due to UDL, so whenever we are showing the bending moment diagram due to UDL, we show a parabolic line. So what I will do, I will go, let's say from here I will start the parabolic line, right, and I will go up, it will go increase till this point where the shear force diagram cuts the 0 line, and then it will go down to point C to 19. You see here? Now it is going to 19, and here let's say this is 19 kilonewton meter. And at the end we know that it is 0, so we will go then straight to 0. Now what happened? We have point A 51, then we have 61, then the force still increases till this point where the shear force diagram cut the 0 line, and then it's going down to 19. Now the question here is, how much is the shear force here? We can do this before even, but I have drawn and then I will find how much is the shear force and where exactly this point lies in the length of the beam, how much it is far from this support. So this is extremely important. We need to find the magnitude here of the maximum bending moment and the location of this maximum bending moment. So how we will find this? For that we have to, so this point we want to find. For that what we will do? We need to find, we know that this distance from here to here up till here, this is 3 meter. This distance we know. Then from here to here it is 2 meter. This distance also we know. And from here to here, this total is 6. This we know. Look here. We know this is 6 meter. And then the last one is 1 meter. We need to find this small distance here from here to here. How much is this distance? If we find this distance, we will know where the maximum bending moment is. And once you know the bending, like the location of that point where we want to find the maximum bending moment, then you have the forces on the left side, just multiply with the proper distances and then you will be able to find the maximum bending moment. So what I have to do, we have to find this x. Now how to find the x? There are different ways, but we will use the geometrical one, which I can do like this. Look, I will draw two triangles. This is one triangle, right? And this one I can make another triangle here. So these two triangles I have. Now if these two triangles I have, look, this angle is alternate angle. This angle and this angle will be the same, because they are in the one line. So alternate angles are always the same. So if I take, let's say, tangent theta of this triangle. So this side, I know that this is 5 kilonewton. You see, it is 5 here, and this side is 19. This side is 19. So what I will do, I have to find this x, which is the base of the small triangle, and base of the bigger triangle will be what? Base of the bigger triangle is from here to here, right? This is the base of the bigger triangle. Now this bigger triangle, how we can find? We know that from here, look, from here, from this point to this point, it is how much? 6 meter. And the small is x, so this bigger will be 6 minus x meter. Because from 6 meter we have subtracted this small x. So now if you take tangent theta in the small triangle, it will be 5 divided by x. I will do this here. Let's say tangent theta in this small triangle is 5 divided by x. And in the bigger triangle, the tangent theta will be equal to 19 divided by this base. 19 divided by 6 minus x. So as this theta is equal to this theta, so we will say that 5 divided by x is equal to 19 divided by 6 minus x. So if you do that, 5 divided by x is equal to 19 divided by 6 minus x. Now we have to solve this for x, right? So what I can do, it will be 5 into 6 minus x is equal to 19x, right? So 5 6 are 30 minus 5x is equal to 19x. So 30 minus 19x minus 5x equals 0. So 30 minus 19 and 5, 24 minus 24x equals 0, right? So if you further solve this, it will be 24 will be equal to 30 divided by, x will be equal to 30 divided by 24, which is 5 divided by 4, right? So 6 5s are 30 and 6 4s are 24. So this x is equal to, if you divide 5 divided by 4, it is 1 point, it is 1.25. So this small distance x is 1.25. The small distance x is 1.25. So if you look here into this, so how much is this point? The maximum bending moment point is away from the zero, or from the left hand side of the beam from here. This total distance will be how much? From here to here. It will be 3 plus 2 plus 1.25. If you add it, this total is 6.25 meter. Now we have 6.25 meter at this point, right? If you go here, it is that point, right? This point is 6.25 and here also. So what we have to do? Now we know the location of the maximum bending moment, 6.25. We need to find how much is the bending moment. So previously we have found at point B, point C, point A. Now we want to find at this point, right? And let's say this point is, point D. I will say this point is point D, right? Yeah, so this point we want to find. Now how we will find here? I will just erase the top one, and I will solve here, so it will be easy. If you want to find moment at this point, we will start all the external forces on the left side of that section, and we will find the moments of those forces. So what we have? We have 17. So let's say the bending moment at point D. We have 17 times the total distance. So total distance we know it is 6.25. Right? Then we have 12 minus 12 times the distance. So from here to D is, how much is the distance? 2 plus 1.25. So it will be 3.25. Right? Then do we have any other force on the left side of the D? We have this small UDL. Which small UDL? This part of the UDL. You see here? This small part of the UDL. And this small part of the UDL will be how much? We know that the UDL, intensity of the UDL is how much? 4 kilonewton per meter. It is written here. So if previously it was on total 6 meter, that's why it was 24. But if it is on this small region is, how much is the length? 1.25. So we will say 4 times 1.25. And where that force will act, the small UDL, in the center of that small region. The center of the small region is what? 1.25 divided by 2. So that force will act at 1.25 divided by 2, which will be here somewhere in the center. This is the point, or that small force. And now this small force will also have moment. That moment we will take into consideration. So that will be, how we will calculate? We will have minus this 4 times 1.25. This is the force, and we want to find the moment times the distance. And distance is what? 1.25 divided by 2. 1.25 divided by 2. This is the distance. So the total moment is 4 into 1.25 multiplied by 1.25 into 2. So these are the forces on the left side of the point D. So this one you have to just do the calculation. You put all these things in the calculator, do the calculation, and we will get the bending moment at point D, that will be equal to 64.1 kilonewton meter. If you solve this big equation, you will get 64.1 kilonewton meter. You can put all these in the calculator. So I will write here the maximum bending moment is how much? 64.1 kilonewton meter. So this is how we find the maximum bending moment, the magnitude of the maximum bending moment, and the location of the maximum bending moment. These types of problem will occur, like to find where is exactly the maximum bending moment and how much is the magnitude, usually when we have a UDL. Because in the UDL, now you see here, the zero line is crossed by the shear force somewhere at a distance which we don't know. So we take the help of the geometrical thing like these two triangles, the trigonometric ratios, we found it, and we found this small distance which was unknown, this x. And then we add it to the all other lengths, we found the location, and once you have the location of any section in the beam, we can easily find the bending moment. So this is how we draw the shear force and bending moment diagram of a beam which has a UDL, the uniformly distributed load along with the point load. Right? So this is how we solve this type of problem. And still, if you are not clear what is shear force, what is bending moment, we have a video, the link is in the description. Watch that video. It will clear your concept about shear force and bending moment. In the next video, we will find the shear force and bending moment, and we will draw the diagram of shear force and bending moment of a cantilever beam due to point load. So that's it from this video. See you in the next video.